Good morning. Welcome to chemistry class. My name is Oyelami Jenetitunde. Today we'll be talking about the topic named elements, compounds, and mixtures. So before I continue, I'll try to tell you to find a very conducive environment to stay so you can understand and be active in the class. And don't forget to go along with your notebook and your pen. So the objectives, the first thing we are going to be looking at is to look at the elements. We're going to know the meaning of elements, and underneath we are talking about the atoms, the molecules, and also we'll know about compounds. Okay, compounds. Under that subtopic, we'll be talking about we know more about the formulae, balancing chemical equation, and as well as instrumental techniques. The last one, which is mixture. Mixtures. Under mixtures, we are going to talk about the category of mixtures and separating mixture. Okay, so over to atomic theory. Our understanding is based on atomic theory put forward by John Dalton in 1807. His theory reintroduced the ideas of Democritus from 460 to 370 BCE. BCE means before Common Era, and other Greek philosophers who suggested that all matter was infinitely divided into small particles known as atoms. So these ideas were not widely accepted at that time, but later revived when he further developed them and experimental science backed them up with practical observation. So from this introduction, you have to see that without experiments, without being tested and trusted, nothing can just be accepted that way. So atoms. An atom is the smallest particle of an element which can take part in chemical reaction. Fine, is the smallest particle of an element, and it can also take part in chemical reaction. So atoms are much smaller to be seen. We know about 20 times 10 raised to power 6 of them will stretch over a length of just 1 centimeter. That's to show you how tiny and small they could be. So here we are talking about atomicity. Atomicity of an element is the number of atoms in each molecule of that element. Is the number of an atom of atoms in each molecule of that element. E.g., we have monoatomic element like sodium, we have calcium, we have diatomic like chlorine, like hydrogen, like nitrogen and oxygen. Okay, so other are like polyatomic, maybe 3, 4, 5, 6, 7, 8, as the case may be. So here you see the table showing some of the elements with their atomicity. So for helium, we have 1 neon like that. Hydrogen, oxygen, nitrogen, we have 2, 2. Ozone has 3. Phosphorus has 4, and sulfur as 8. Elements. There are distinct substances that cannot be split up into smaller substances. Such substances consist of only one kind of atom. For instance, in aluminium elements, you can only see atoms of aluminium in there. Okay, elements is usually symbolized by a capital letter or a capital letter followed by a small letter derived from either English, Latin, or Greek name of the element concerned. E.g., you see hydrogen, is capital letter that begins the hydrogen, which is H. Sodium is derived from the Latin name Na. Same thing with copper. Uranium is derived from the name, the first letter of the name, which is U, capital U. Antimony, SB, neon, and so on and so forth. So you can see here some of the elements that take after their Latin name. Take either the first capital or first and the next one small letter. So you have sodium, Na, nitrogen, okay, potassium, you have calcium, like that. You can have a look. So element can be categorized in several ways. The first category is based on natural radioactivity. Elements under this categorization, you have two types. You have radioactive elements. As we all know, radioactive elements are elements that can spontaneously decay or they degrade, okay, by emission of either alpha, beta, or gamma particle. So same thing with the second one, non-radioactive element. That means they don't undergo radioactive decay, they don't decay, and they don't also emit alpha, beta, and gamma ray. So the second categorization is based on properties. When we talk of properties of elements, you can categorize that into three. We have metal, non-metals, and metalloids. Okay, metals, we all know they ionize by electron loss. So these are the examples there. And generally, metals ionize as follow. M stands for metal, so they lose out their electron, becoming an ion. That's Mn plus. N can stand for 1, can stand for 2, 3, like that. So this is a real example. We have sodium, that's Na plus, because group 1 element. Same thing with this group 2 element, and aluminium, which is group 3 element. So metal possess the following physical properties. The first property is that they are ductile. Ductility and malleability. That means they can be stretched into wire. That's what ductile mean. Malleability. That means they can be armored. Okay, that's why they are good in construction works. The second one is that they add solid with high melting and boiling point, except sodium, which is soft, and also mercury is liquid metal. Then they are lustrous. Lustrous means they have shiny appearance, okay? They have shiny appearance, that's why they are used as jewelries, they are used as paints because of their reflective nature. Then the fourth one is that they are sonorous. When they are sonorous, that means they make deep sound, okay? Vibrating sound, that means they echo. That's one property of metal too. Then good conductor of heat and electricity. We all know that they conduct because of their high temperature and boiling point. They can easily conduct electricity. Okay, so when we talk about general chemical properties of metal, we are talking about the first one is that most metal combine with oxygen to form basic oxide. Okay, they combine with oxygen, such as giving you copper oxide when copper combine with oxygen, magnesium with oxygen, calcium with oxygen. However, some metallic oxide are amphoteric. Okay, note, some are what? Some combine with oxygen to give us basic oxide, while some of them are amphoteric. When you say an oxide of metal is amphoteric, that means it can behave as an acid as well as a base. So these are the examples of those kind of metallic oxide that can be amphoteric. Then the other one is electropositive. That means they easily lose electrons to become ionized. That's what makes them a good reducing agent. Okay, the third one is that they combine with chlorine to form electrovalent compound, just like we have in sodium chloride, calcium chloride, magnesium chloride, and all that. Can go on and on. So the fourth one is that they form metallic hydride that are ionic. Okay, they are, when they combine with hydrogen, they form metallic hydride, and they are ionic. They are ionic, they are strong. They have high boiling and melting points and all that. So the fifth one is that they replace hydrogen in an acid if more electropositive than hydrogen. That means if they are in higher place in electrochemical series, they replace hydrogen from the acid. Okay. The other one we are going to talk about under properties of element. You know, the first one underneath that property is talking about metal. This one is non-metal. So when we talk about non-metal, they are what? Elements that ionize by electron gain. They gain electron, while metal ionized by loss of electron. So the ionization of non-metal is as follows. So when you have something like this, and you have half of this, that means you just have one atom of that thing. That's what it simply means. Just by dividing 2 by 2, give you 1. Okay? So when this combine with this, where N can be 1, 2, 3. So these are the real example where you have chlorine gas losing out or gaining electron to become ionized to chlorine ion. Okay, same thing with oxygen, gaining 2 electrons from the corresponding metal to become ionized and all that. So non-metal are therefore oxidizing agents. Okay, they are oxidizing agents except for a few of them, since they undergo reduction in their ionization. You know, they reduce from like 0 to minus. So that's why they undergo reduction. So hence they are good oxidizing agents. So some physical properties of non-metal: they are brittle, just opposite of metal. They are brittle, that means they can easily break. Okay, they look dull. They are not as lustrous as they are not sonorous. Then they have low density, though some of them can be heavy, such as diamond. Then also diamond has a very shining color. So diamond actually has this property of a metal. Is an allotrope of carbon. You know, is a form of carbon. Some non-metal dissolve slightly in water without reaction, e.g. oxygen. So though some dissolve in water with reaction. Under that you have the chlorine, you have bromine gas and all that. So these are the example of general chemical properties of non-metal. The first one is that they are mainly oxidizing agents, just like we said earlier on. They form acidic oxide, mainly carbon 4 oxide, that's sulfur 4 oxide, then nitrogen 4 oxide. These three form what? They form acidic oxide, and the acidic oxide are known as acid anhydride. That's the name called the acidic oxide. Acid anhydride. They are acid anhydride because if they are dissolved in water, if they are put in water rather, they give an acidic solution whose pH is less than 7. You know, when something is less than 7 on pH scale, that means it's acidic solution. So this is it. Example, you have CO2, which is carbon 4 oxide, reacting with water to give us this. And this is the ionized equation. Okay, same thing here for sulfur 4 oxide in water, we give you this, and this is the ionized equation. Same thing with nitrogen 4 oxide with water, we give you this. So some non-metal form neutral oxide. These are the examples. We have carbon monoxide and nitrogen 2 oxide. So both metal and non-metal show polymorphism. You call it polymorphism, or you call it allotropy. That situation is an occurrence of an element to occur in more than one form. That's why we have in carbon, we have carbon in 2 forms, graphite, diamond. We have red and white sulfur. We have red and white phosphorus. We have oxygen, dioxygen, and trioxygen. Okay, we have them like that. So the form in which metal occur naturally is known as ore. Okay, and metals are at times mixed intimately with other metals or non-metals to form alloys. You've heard about alloys before. So they combine like that to protect the property of each other so they can last longer. So for metalloids, that's the third one under properties of elements. They are elements that are neither distinctly metallic or clearly non-metallic. You have examples there. We have silicon, we have arsenic, we have tellurium. And the property of metalloids are intermediate between those of metal and those of non-metal. For instance, they are semiconductors. You know, we said metals are good conductors of heat and electricity, while non-metal are poor conductors. But for metalloid, they are semiconductors. So, hope you get that. So, we'll move to more about formulae. That's plural formula, okay? So word equations are a useful way of representing chemical reaction, but a better and more useful method is to produce a balanced chemical equation. If you write an equation and it's not balanced, it's not useful in chemistry. Although most of our equations come in unbalanced, but you have to balance it. So balanced equation often include the physical state symbols. Okay, at times you see subscripts. This, which is S, stands for solid, L stands for liquid, G stands for gas, AQ stands for aqueous solution. That means it's dissolved in water. Then plus, if you have plus, maybe sodium chloride plus, that's if you have it on the reactant side, which is left hand side, that means it's reacting with another one. But if you have it on product side, it simply means and, whereby you have two products to be so and so. Okay, so for headed arrow means it produces or it yields. Okay, then at times you might have this triangle on arrow, that means it is being added. Then at times you have a compound on an arrow, that means they are telling you is helped, the reaction is being helped by a catalyst. You know, catalysts don't take part in reaction, they only speeds up the rate of chemical reaction. So the word equation, for example, this is what we're going to do today. The word equation to represent the reaction between iron and sulfur. This is iron reacting with sulfur. Don't forget, plus at the reactant side is react with sulfur, which produces or yields iron 2 sulfide. So when word is replaced with symbol, this is what you have. Okay, and it is being added to give you what? Note, solid is there. You have to put all those symbols there. They are physical symbols that you cannot do without. Okay, this is a balanced chemical equation, that is, atoms on both sides of the equation are equal. So we move to instrumental techniques. Instrumental techniques are ways by which we normally find out the composition of compounds or elements. Okay, the development of instrumental techniques by scientists help us probe and discover which elements are present in the substance and how atoms are arranged within the substance. So instrumental methods that have been developed are quite sophisticated. For example, we have the atomic absorption spectroscopy. This one allows you, or allows the element to be identified. Okay, as a scientist, you can identify the constituents of an element using atomic absorption spectroscopy. And you can also know the quantity of the element that is present in that element or compound. Okay, so infrared spectroscopy. This one is used to identify compounds. Okay, by showing the presence of particular grouping of atoms. It will show you how many atoms and the atoms in that compound. So this is used by pharmaceutical industry. They use it to discriminate between drugs that are similar. Okay, so sample can be solid. The sample being tested by these instrumental equipment can be solid, can be liquid, can be gas, and they are very tiny, just little of it that you need. However, neon, helium, oxygen, nitrogen, and hydrogen cannot be used. I hope you know the reason why they cannot be used anyway. They could be heavy, because all you need to use is just tiny. So forensic scientists make use of both of these techniques because they are very accurate but only require tiny amounts of sample. So other techniques that you can use are what? Nuclear magnetic resonance spectroscopy, and you can as well use ultraviolet visible spectroscopy. So we move to compound. Compound, these are substances composed of two or more kind of atom. So you can see, you can have elements or two elements or three, as the case may be, in a compound, joined together in definite grouping. Mark that word, definite. Okay. So compounds are usually represented by chemical formulae, just as symbols represent elements. Okay, this is a compound, this is a compound. You know, two atoms can join together to make a compound. As well, two can join together, which is between diatomic oxygen and carbon coming together to form carbon 4 oxide. So how can you categorize compound? They are based on behavior when exposed. You know, you can categorize them based on their behavior when they are exposed to the atmosphere. The first one under that category is the liquescent. Okay, compounds that absorb moisture from the atmosphere to form solution of that compound are referred to as the liquescent compound. These are their examples. And hygroscopic is those compounds, when you talk of compounds that absorb moisture from the atmosphere and become wet, but they don't form solution. They become wet, but there's no solution being formed. These are their examples too. They're efflorescent. When you talk of compound that gives off their water of crystallization, for instance, disodium triisocarbonate 4 decahydrate, that's 10 water. It normally loses 9 mole of the water, remaining 1. So that's a fluorescent compound. Okay, so the liquescent and hygroscopic compound are used as drying agents in lab. Okay, the second one is based on nature or property of the compound, acid, salt, or what have you. The mixture, you can call something mixture if they fall under all this, if the substance fall under all this category: composition indefinite, consistently retain their identity, reacts differently to change condition. So those are the kind of substances you can refer to as being a mixture. Then under mixture, we are based on phase coexisting. When they are coexisting in different phases, they are heterogeneous. When they coexist in same phase, they are called homogeneous. Same thing with we talk about different separation techniques. So, you know, in a mixture, you might have a very useful and impurity. So you use all these methods to separate them, and different ones, as each of them has their own use. So you have to know about their use and how to inculcate the separation, the habit of separating different mixture, and how to, you know, under this you look at it is between solid and liquid. This one is between liquid and liquid. When you have mixture of liquid, this is what you use in separating. If you have solid and liquid, those are the methods you can employ. And when you have solid and solid, use these two too. So how can you know that a compound is pure? Criteria for purity. Purity can be measured by the melting point. They must have sharp melting points. Same thing with boiling points also, and the chromatography technique. So those are the three you can use. So for your class drill, you have to list all the differences between mixture and compounds, write what equation and balanced chemical equation for all these ones. And for more exercises and explanation, you can check these three, any of them. If you have any of them, that's fine. If you have three of them, you can just compare and contrast, so you can have more knowledge of what we just did. Have a great day. Enjoy your day.